The main problem we are addressing is the waste problem. I'm sure you are very familiar with the workflow that goes from the computer-aided design to the final metal component. So the problem with this workflow is there's a disconnect between the CAM programmer and what's happening in the actual machine. So CAM software are doing a lot, but they are mostly limited to the geometry of the process. They cannot help the CAM programmers with the physics of the process. So the manufacturing engineers or the operators see the problems themselves when they press the cycle start button. There may be an excessive noise coming from the machine. There may be a tool breakage issues, or nothing might have happened in the machine. They go back, they go to the CMM, check it, and then they see some problems, and then they come back to the CAM. So most of the important decisions are given in the CAM, and then there's an iterative cycle that starts. So typically 3 to 5 iterations is probable and happens a lot. And these iterations are causing extra waste in the sector. And also, after these iterations, maybe 3 or 5, somebody says, good enough, lads, don't touch it. So, and then they start producing this part for months or years. And we know that most of the machines that we have in the sector are not using the maximum potential of the machine unless the companies have done a lot of iterations on their machines, which is not feasible most of the time. So we want to address the waste of resources. We want to address the underutilization of the machine tool performance with our solution. And how we do that? We basically have a plugin inside SenseNC CAM and other CAM software. We have to have a toolpath generated. So there needs to be a toolpath available for us to work on. But you don't have to enter the feeds or speeds. You can enter it so that we can show you what was it before and what is after. So to make a benchmark before and after, we look to what is the original feeds and speeds. But for our optimization to run, you don't have to enter any feed rates or spindle speeds, unlike the other solutions in the market which does process optimization. What we do is we basically autonomously optimize the spindle speed and feed rate to solve the problems related to the physics of the process.